Hey mathematicians! This video is a refresher on how to find the area of rectangles and or squares. Okay, so when we have a shape, we're looking for two different things. The area, which is the number of square units that fit inside the shape. You can see the outline here, and we actually see squares inside it. So there's like one little square, two little squares, three little squares. If you have an image, you can just count them all up. But that can take a long time, and especially if you don't have an image that's already cut up into squares, we don't want to have to draw one. So we're going to figure out how to calculate the area without counting individual squares. But speaking of squares, when you do say how many squares there are, you measure them in square units, or units squared. So this would look like, if this is in inches, you'd say inches to the second power. And we'll talk about why that is in a second. The other thing we're looking for right now is perimeter. Perimeter is like if you had to put a fence around the shape and you started here and you counted all the numbers all the way around as you kept walking until you got back to the start. So for both of those things, we kind of need to know two different dimensions. They're called the length and the width of a shape. The nice thing is that there's no rule about which one is the length and which one is the width. We also call them the base and the height, because the answers would be the same if you turned this shape on its side. So it doesn't really matter which one you use as which, but we do need to count them. So counting the sides, we have a side length of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units, and we'll label that here. I did not tell you what they were, so if you don't know, you can just call them units. And the height is 1, 2, 3, 4, 5, 6, 7, 8. 8 units tall. Now notice that when I was counting squares. Another way to count is to count from one corner to the next, and jump like that. But what you don't want to do is just count the lines in between them, because then you would be off by one, because the number of lines is not actually the same as the number of spaces that those lines cut your shape into. So make sure you're just counting squares and not lines between squares. Okay, so the faster way, other than counting individual squares inside this entire shape to find the area, is to multiply them. Because what we really have is 8 rows of 12. Here's 12, here's another 12, here's another 12, and another 12, all the way up to the top of the shape. Now you can add those, 12 plus 12 plus 12, 8 times, but really that's multiplication. So we're going to say 12 times 8. 12 times 8 is 96. 96 units squared, which looks like an exponent of 2. Or if you wanted to write out the word squared or in front of units, write square units. That works too. The reason that they have an exponent of 2 is because we multiplied the 12 times the 8. And in doing so, we also multiplied the units times the units. And as we know from our exponents lesson, anything that's the same that gets repeatedly multiplied, we can show it in a simpler way by showing it an exponent of how many times you're repeatedly multiplying units times units. So this area is 96 units squared. The perimeter is 12 plus 8 plus 12 plus 8. You can do 12 plus 8 is 20 plus another 20, or sometimes some people like to double them and say 12 plus 12 is 24, 8 plus 8 is 16. Together that makes 40, because 20 plus 20 is also 40. Perimeter is only units. There's no exponents there, because we did not have to multiply anything to get our final answer. We added units and more of the same units. We're still, if we took our perimeter and straightened it out, we would have a straight line. It would not be counting 2D shapes inside it. So units, no exponents. We can also use the formula, which will be on your reference sheet. A, area, equals BH. B stands for base, H stands for height. And remember, when you see two variables really close together with no symbol, that means they're being multiplied. So you can find the area by writing your formula. You always want to write your formula. Oops, I lost my pen. Area equals base times height. I don't know the area, so I'm going to keep writing A. I do know my base is 6 inches, I do know my height is 2 inches. Notice how I added a multiplication symbol there? You could have also said 6 times 2 like that, but I do not want to just write 6 and 2 because that looks like 62. And while I can put them really close together when they're letters, when they're variables, and it means multiplication, if I put 2 digits, 2 numbers really close together, it just looks like it's making a bigger number, like 62. So you need some kind of multiplication symbol. And then you would say that your final answer is area equals 6 times 2 is 12 inches squared. This also works when you know the area and you're looking for a missing side length. You always start with your formula. Area equals base times height. We know our area, so we're going to write 88. Notice how I'm not bothering to write my units when I write my formulas. Formulas don't include units. You add them at the end. 88 equals, well, you can say 8H or you can say B8. Basically, we're just saying 8 times the other number. Because like I said, you can have a rectangle that goes like this with a height of 8 and a base of, we don't know. And you can have the same rectangle on its side and it doesn't really matter. So 8 times something equals 88. Well, we can always do the inverse operations and say divide by 8 on both sides of your equal sign. 88 divided by 8 is 11. And that equals, I'll call it B because our base is usually on the bottom. 11, don't forget your units at the end. Our base equals 11 inches. Some people will get confused and put an exponent of 2 and say inches squared, but this is not area. This is just one length, and it's not squared. It's just plain old inches.